Hello everyone and welcome along to MPhil Physics Tutor makes tough physics easier. Today we're going to look at Newton's second law as part of my mini-series on Newton's laws. And yes, we're going to be talking all about F equals ma. And by the end, hopefully you'll have a clear understanding of what do you do with the resultant bit. On one level, Newton's law is really straightforward. It's just F equals ma. But on another level, that's okay, but really it would be much better to say that resultant force equals mass times acceleration, or F little r equals ma. Now, not all textbooks will write it like that, and not all websites will show it like that, but really that is better. In this first example, which we've made deliberately easy, you can see we have a car of mass 50 kilograms and an acceleration of 3 meters per second, and we have to find Fr, the resultant force, which of course we know is m times a. So that implies that it's going to be 50 kilograms times 3 meters per second, and so our resultant force is going to simply be 150 newtons to the left. Simples. When an object has two or more forces acting on it, so for example a driving force and a resistive force like air resistance or friction, then what do? Well, the resultant force that you're going to use in Newton's second law, F equals ma, is of course the difference between the force going that way and the force going that way. Take a look at this example. We are going to use F equals ma, and we've been asked to find the acceleration. We're given the mass, and we'll come on to the resultant force, Fr, in just a moment. So if we want to find the acceleration, we're going to divide both sides by m, which will give us that the resultant force over m equals a. What are we going to do about this resultant force then? Well, the resultant force is simply the difference between the force going right, which is 300 newtons, and the force going left, which is 75. And that gives us a resultant force to the right of 225 newtons. Therefore, our acceleration is simply going to be 225, resultant force, divided by the mass of 50, which comes out as 4.5 meters per second squared. If you are really smart and really on the ball, like I know most of you are, you will look at F equals ma and the calculations that we've done so far, and you will say, ha, I've seen this somewhere before. And yes, of course you have. Newton's first law. This, remember, tells us that if the resultant force on the ball is 0, then there is no force on the ball, obviously, which means there is no acceleration on the ball, which means that its velocity stays the same, which means that its velocity is constant, which of course could mean that it stays stationary. In other words, Newton's second law is just another way of stating Newton's first law, but this time putting some numbers into it. So really, they're the same thing, they are equivalent. If today's video was useful, Betty the Physics Dogs recommends that you go here to look at the video that I made on the normal force.